This is the video for CS 121, Chapter 8. We've already talked about lists quite a bit. We know how to assign a list and put elements in it. They don't have to all be the same kinds of things. We can also assign a list by using the list function. We know that we can go to a particular index in a list. Indices start at 0. Lists are mutable, so that means you can change them in place without having to replace the whole list. So that grow or shrinking them with functions or with methods. I can take part of a list and assign it into another list. I could also put a stride on here, so I could take every other element from a list. I can add two lists together and assign them to another one. I can reassign, change the value of the ith element in place. I can go from the length of my list to the end and make sure that I'm adding the list to the end of a list. I can also delete my list, so del my list, a particular element in the list here. You probably could also delete, like from a start to an end, that part of the list. My hint for the 8.2 lab is to use integer division. Remember, that's 2 forward slashes. For 8.2, you're going to use the count method in order to get the count for each element in the list here. So this one, it goes straight through the list. There were 5 elements there. So you'd have to split it first and then go through one at a time and count how many times it was there using the count method. In 8.4, there are more methods. Some of them we've seen. The list.append adds an item to the end. List.extends means that you can put a whole list at the end of the list. And you can also insert one at the I position. So here, if I wanted it at the second position, I would say my list insert 1, that's the second position, and 1.7. So basically, it looks like if I was going to do a replace, that would put it over the 8, but I'm not replacing, I'm actually inserting. We can also remove an element, and it'll remove the first item from the list with the value. We can pop, remove, and return the last item in the list. This pops off the very last one. Pop I removes and returns item at position I in the list. So pop just gets rid of the last item. This one you can actually tell at which index. We have a sort method here, and really this mylist.sort needs a print statement after it in order to print this out. The same is true for mylist.reverse. You need a print statement afterwards to see that the list is actually reversed. This is a permanent sort, so if you wanted to retain the locations of your original list, you want to make sure that you're not overriding. This will change my list to be the sorted list. This will change my list to be the reverse of the first list. List index x returns the index. So this is just getting the index, and here's the count function that was talked about in the last lab. Remember, for the average, that you'll need to get the sum of the list divided by the length of the list. We have functions for both of those, not methods, but functions. In 8.6, they talk about sorting a little further. This again shows you my list sort is the sorted list here in order. And if it was an alphabetical list, it would sort it in the ASCII order, depending upon how long the strings were too. So in order to actually see this list, you'd have to print it out. This would not print that list. So there's a quick little program here that shows you that if you enter some stuff, then you can sort it, and it'll put it out in alphabetical order. So we're printing these in alphabetical order. There's an additional function in this case, sorted, with parentheses that you put a list into, instead of the method, which is performed on a list. This sorts a list in place. This sorted function allows you to take a list and create another one that's sorted. So this is assigning the sorted list without changing the original. For the sorted functions, you have a key that you put in here that doesn't change the string, but it considers all the elements in the string to be lowercase. So without the key here, the names are in alphabetical order according to the ASCII order, and capital letters come before lowercase. If you put string.lower, then all of the first letters here would be considered as lowercase, so J, R, S, V, they're now in alphabetical order the way that we see them as being in alphabetical order. There are several arguments that you can use in this sorted function, and one of them is the reverse. If you say reverse is true, then it's going to send the sorted one out in reverse. This asks for 4 numbers to be entered. I recommend you do this with the for loop with a range of 4. And you could start 1 to 5, in which case you get these 1, 2, 3, and 4 as your argument in the range there, or in the for loop. For this lab, we're going to input a string, and you'll have to split it and put it into a list. Now, if you're going to append to a list, you have to have an empty list first. So those are the things we've studied so far, but just a little reminder. You need an empty list first. An empty list looks like this. Integer list with some brackets. So we're going to get an input and split it. We're going to have the list, and if we need to make it integers like this, we have to actually say that it's integers. Everything that you get into a list like this, especially if you want a list of numbers straight across, will be strings, and you have to convert them to integers. We have already iterated over list using a for loop. So my variable can be anything here. You might call it element. Sometimes if you put something in that makes you think I, like an integer, it causes a little confusion because this isn't getting the index, it's getting the element in my list. So the for loop here, tokens is the user input split. So these numbers were put in. And then for tokens and tokens, nums.append int token. So we're taking those from the split and putting one after the other into our list. For the index in the range length numbers, we are getting a number out of here. The index is the I, and the value is the nums at index. So it's the element from the list at that index. So this is going one token at a time through the list, and this is going through by the index. A typical error is the index error if you use an index that is outside of the range of that particular list. So always be aware of how long your lists are. Length list is the easiest way to make sure that you end up with the correct length for your list. In this program, they actually have the sum is 0, and they're adding the sum of the list up this way. But we have a sum function, so these lines here could really be replaced with sum equals the sum of our list, which was called nums. So in some of this code, you're going to see more code than is actually needed because we have better functions or methods, or more efficient functions and methods. Not necessarily better, just more efficient. They say the enumerate function iterates over lists and provides an iteration counter. So you can enumerate tokens here, and that actually gives you a position starting at 0. So for each one of these, you have a position and a token. So if I run this, I get the 0 index had 203 in it. These were the numbers that were there. All the way down to the 4 index, 0, 1, 2, 3, 4, has negative 10 in it. And then if we add them up, we end up with a sum. They want you to put an average in here, and remember that the average is computed by dividing out the length. We have a few more built-in functions for list. We've already used max, min, and sum of the list, so these we're familiar with. All list is going to return a true or false depending upon the list, and it returns true if every element is not equal to 0 or if the list is empty. So this one has a 0, so that returns false. The first list does not have a 0, that one gives you true. Any list is going to return true if there's anything in the list that is not equal to 0. So if there's anything in the list that's not equal to 0, you get a true. Here, there was nothing in the second list that was equal to 0, so we got a false. For the 8.9.3 challenge activity, you have a list of numbers, and you want to include an arrow in between with spaces. So for each number, you have a space, an arrow, and a space. But you only have a space after the last one, and then you want a new line. This will require a for loop, and you'll definitely have an if to determine whether or not the arrow needs to be printed. List nesting means that you can have list and list, like this, list and list. And then you can call on each one of those. My list 0 would have the first list, my list 1 would have the second list, or you could look for my list, the 0 element, that would be the first one here, and the 0 element would be the 10. This list nesting is the way that we use multi-dimensional data structures. So this looks like a matrix here. There are lots of operations available for matrix kind of notation in Python. For 8.12.1, if I run this with 1, 2, it's going to go to the first element and the second element in that first list. So that'd be 2011. Scrolling down, I can see that my user input is split into 2 pieces. Those are both strings. To use those as indices for my matrix, for my multi-dimensional list example here, I have to change these to integers in order to use them for the indices. Be sure that you study these nested lists really well. You can use nested for statements to get the whole list out like this. So for each row, that's everything in currency. So currency has 3 lists in it. I want to go to each cell. So in the first list here in currency, I'm going to go to each one of these cells and print cell. So I'm printing each one of these. This is how I print out this nested list. 8.12.4 gives you another example of how to use enumerate here. We want to pop the index out so that we can say which currency, here's our currency, which element of currency I'm using. So we have the row index, so this keeps us from having to put a range here, and the column index. All we have to do is enumerate, and we end up with a row and column indices so that we can refer to them in any printout that we would need. In Chapter 7, we looked at string slicing, and it just means to take like a little subset of the string. The same is true for the list. So here we have a list with 3 elements, and this one says to take from 0 to 2, which means not including 2. So that would be 0 and 1. So Tyler and Zdeno. This one says to start at 1 and go to 3, not including 3. And of course we don't have a third index here, so we couldn't do a third index. That would give us an index error. So here we want Zdeno and Patrice. And the stride is the same as what it was for the string also. You give a third argument here. The first one is the beginning, the second one is the end, and the stride would tell you how many you're going to go through to get there. So this is a stride of 3 starting at 0. So I do 0, 1, 2, 3, and all I need is 5 and 40 there. I could start at 2 and go to the end. So 0, 1, 2, I'm starting at 2 and going to the end. I could start at the beginning and go to the third one, third index, the fourth element, the third index, 0, 1, 2, 3. Or I could do the entire list. So this does the entire list. So if you leave these blank, you get the entire list. Now lists are mutable anywhere, so of course we can modify them during a for loop. But if you wanted to add 5 to every element in the original list, this would be a way to real quickly add 5 to it. Like if you wanted to add bonus points of 5 or curved scores of 5 points in all of the grades that you have in a Python program. Down here they also use enumerate so that you can talk about a particular position and value. A common error is to add or remove an element in the middle while iterating. So that means while you're going through a for loop or some other kind of iteration scheme. So here if I remove an element from a list and I'm trying to see if it's in the other list, then it stops checking for it and I get erroneous results. So look at this kind of carefully. It's not that big a deal, but you do want to be sure where you're adding and removing elements outside of iteration schemes like for loops. List comprehension is a short construct to be able to make a new list if you know exactly what you're doing with some other lists. So the iterable here could be a string or a list or some other sequence. So for my list, for each element in my list, so that's 10, 20, and 30, so the I here means the element in list, not the index. we're going to add 5. So now we'll have 15, 25, and 30. 5. So this is like a regular for loop. It has all the things for I in my list, so that's an element of the list. I'm going to do this. So I'd have to have 3 statements here in order to get this done. I would have to write the new list plus 5 is equal to an empty list, and then I'd have the for statement with the colon, and then I'd have new list plus 5 dot append the element in my list. So this takes out 2 lines of code. So the short comprehension code is a little bit more efficient than writing the 3 lines. But sometimes it's better to see 3 lines. These are some examples here of when you can use the list comprehension to replace. So it's what we had over here, and we're replacing it with list comprehension, which is here. So 1 line of code for 3 lines of code here. It looks like 1 line, 2 lines, but it's really only 1 line of code here. So you want to carefully look down through these because the efficient code here sometimes makes it easier to understand what you want things to do in your program. To the list comprehension, you can also add an if statement. So I'm going to add each of the numbers here and the elements in the first list, which they give us, the first list, if they're divisible by 2, which means they're even. So it's only going to add 52 and 16. So not only can you have a list comprehension, but you can add a conditional to it. So you have a conditional list comprehension. 8.16 goes over command line arguments. There aren't any labs that you have to work with this material, but there are some quick little activities for you to do to explore what this material might mean. If you've had linear algebra already, or linear programming sometimes is what it's called, then you've seen this matrix multiplication. If you've not seen it, this can be a little bit challenging to understand. So you don't need to spend much time thinking about this. If we have further examples with this, I'll provide you more material on matrix multiplication, but it's usually not very heavily explored in a first semester Python course. I'll put a second recording in for dictionaries. But I wanted to show you an example of the list program that you might write. So I'm importing math here because at some point in here I want to do some interesting math, and I want to also review that you can import math and do things like the power. So I'm raising 2 to a power in a range, or the square root, and taking the square root of a number here. So if I run this program, I first have a blank line. There it is. List 1, list 1A, 1B, and 1C are there, and then in list 1 I deleted the first entry. So when I deleted that first entry, it removed it from list 1, but it also removed it from list 1B because list 1 and list 1A both point to the same location. It means they're exactly the same list. Anything you do to one list, you do to the other. If you want a copy, you'll need to put list 1 with a colon in brackets like this to get a copy. There are other ways to do a copy, but this is the easiest one. So if you definitely want a copy of the list, then this would be the easiest way to do that. So if I go to print this out, I have list 1, list 1A, list 1B, and list 1C. So here's list 1, and I removed element 1 from it. So that was the 2. So list 1 should be 1 and 3. List 1A is also 1 and 3. List 1B is the whole list because I copied that whole list and I didn't change list 1. List 1C is list 1 plus another list. So this adds more. It puts list 1 in as a copy and adds more. So this does not update with list 1. So it's not saying that list 1C is exactly list 1. We're not making a copy of list 1. We're inserting it in with another list into list 1C. So when I print these, here's my list 1C with both the lists put together. I can reverse it, but this line of code doesn't print anything. It just reverses the string. So now anytime I call on list 1C, I will see that in reverse. So it just reverses the order. Now the next thing I wanted to do was print out everything in a list that I'm creating that is 2 raised to a power. So the first one is 2 to the range of 20, so it would be 2 to the 0 power, which should give me 1. Notice that this is printing out with decimals because the math.pow automatically gives me float. So the list 2 I'm appending, which means I'm adding one element at a time to my list 2. I started with a blank list. This is an important concept. You need a blank list before you can add to it. Append is how we add to it, and there are other ways to add to it. And I can print list 2 one at a time. Notice here the negative one. That means I'm going to print the one I just added. It's the last one in the list. List 2 with a -1 index is the last one in the list. If we print, I'm going to do this again, and instead print with the integer part of the list 2, that means it's going to truncate all of the decimals off the end. So if I run this again, then I can see I have no decimal places. And of course I could also run this with formatting. So I want it right justified, so I line up the decimal places correctly, and I'm doing it with the variable a, where a is the string of list 2 -1. So I took list 2, which is now an integer, converted it back to a string, and printed it. I don't need to convert it to a string to print it, but I did here because I wanted to show you that you could. So now if I do this, I should see it printed lined up like this. But notice I didn't convert it to an integer first, so it's giving me the float value. So I'd have to convert it to an integer, or make this an integer here, for this to print it out with no zeros. So in int, run module, and I get it printed lined up with no zeros. So that's just playing with how you're going to get some of your output. I could have also just formatted this for no decimals. After I've printed out these numbers 2 to the power, I also put a blank line in. There it is. And then I wanted the list 3 that had the square roots in it. Now this is that comprehension notation. I want the square root of I for I in a range from 2 to 11. So then for each element in the list, I want to print it out. So I printed out the entire list here. Notice that I put a space in between them. All on one line, the entire list of square roots for 2 to 10. So I should see square roots for 2 to 10. There's the square root of 9. That one I recognize right away. For the next part, I want to print out these square roots here without any formatting. So here I had formatting. And then I printed list 4 so that it kept just the ones that were odd. So it's starting at the first index and going up to the end index, all the way to the end, by 2. So we'll be printing out the first index, the third index, the fifth index, and notice there's no formatting here. So I've taken part of list 3 and put it into list 4, and then I printed list 4. For the next part of the program, it's asking for an input. Then I'm going to split it, and then I'm going to make it an integer, and then I'm going to sort it. So for everything we're doing here, we can put this in really condensed notation. Comprehension notation is what it was called. But it's got a for loop, it's got a split, it's got an integer, and it's going to sort it. So whatever I put in here, and I'll go ahead and type 1, 19, 2, 18, 3, 17, 19, 4, and 2. So I just put a list in. So that's what my list looked like. So it sorted it. 1, 2, there were 2 2s, 3, 4, 17, 18, 19, and there were 2 19s. It sorted it, and then it kept the odd numbers. So that's what this code says. So print list in. For elements in input dot split, we sorted it. So there's the sorted list. And then we kept the odd numbers. So for I in range length list, when there were odd numbers, I printed them out. There's a shorter way to print these out too, so you might consider how that would be done. Then I wanted a blank line after that, but a blank line just took me to the next line here because This is where I am. So for the next part of this program, I'm using list string is equal to the frost is on the pumpkin, which I think you had in the last test. I'm splitting that up, and then in addition, I'm going to take that, print out the first index, which is frost, and the third index in frost, which is 0, 1, 2, 3, the S. So that's where the S comes from. So that's the nesting that I was talking about. I also want to split each of the words in here into individual elements. So I've given you some code here that helps you to understand how to do that. So basically it says, I'm going all the way through the list string, that's the frosted on the pumpkin, and it's split into list string. So that's 1, 2, 3, 4, 5, 6 indices. So 0 through 5 is what that is. So the length list here would be 6, the length of the list string. So for each of those 6 things, I'm going to go list of list and append, creating the list string ij for I equals. So this says in the range of length list string I, so for the ith one, and I probably could have done this with an enumerate, and that would have been okay too. So I probably could play with the enumerate here and get a little bit more information out of this. And then I printed the list of the list. So this is a list that contains 6 lists with individual characters from each one of the words. Just a little more code that you can see a little better how things might be working. I'll include this code on the resource page.